Hi, welcome to the first hour of Understanding Modern JavaScript Frameworks, a new course I've created that I think is sorely needed for web developers and does not exist. It's something very unique. So what is this course? Well, it's not going over how to build a to-do app in various frameworks. Instead, we're going to dive under the hood of the concepts that all of these frameworks share in one way or another and how they work under the hood. I'm going to take you under the hood of frameworks like React, Angular, Vue, Solid, Svelte, Qwik, TanStack Start, and we're going to get an understanding of the problems they're trying to solve and the different ways they solve them. We're going to go inside their source code and see how they really work. We're going to look at concepts like bundling and components, RPCs, server functions, reactivity with signals and virtual DOM. We're going to look at how these things work so that you can grow beyond just being a user of an abstraction that you don't understand, so that you can guide an LLM to generate code properly, so that you can debug when there's problems, so that you can move from job opportunity to job opportunity without fear, even though it may be a framework that you haven't used before. And the ability to grow beyond being a dev that closes tickets, but to be someone that's a senior dev, a lead dev, an architect. And in this hour, you also see the exercises that I've set up for this course that are unique. I'm calling them Stack Dive Challenges. You'll get 2 in this first hour, where I challenge you to go under the hood of the frameworks that you use every day. So I hope you enjoy this first hour, and you can find a link to the full course in the description of the video at don'timitate.dev. Enjoy. Web development has gotten complicated. It seems like there's always new things to learn, new techniques, new complications, new frameworks. In this course, we're going to go under the hood of how modern JavaScript frameworks work. Because across the board, they share certain goals and certain ideas are repeated. If you can understand how modern JavaScript frameworks work, you can use them well, debug them well, make good architectural choices, and you'll find it much easier to switch to whatever new technology, idea, or framework comes along. So in this course, we're not going to focus so much on how to use every aspect of all these frameworks, but instead, we're going to zoom in on particular ideas that we find throughout these frameworks, why those ideas exist, and how they really work. In doing so, we'll follow a motto that I follow with all of my courses. Don't imitate, understand. That means it won't be about just parroting the code that I'm writing. We're going to go under the hood of these frameworks so that you have the kind of deep understanding that makes you comfortable when you sit down to write a line of code or to direct an AI to do so. In this age, large language models are writing a lot of code for us. But if you don't understand what that code does and how it works under the hood in a real-world job situation, you'll get yourself in a lot of trouble and perhaps suffer from imposter syndrome, feeling like you're doing things, but you don't understand really why they work. And that also leads to problems when debugging, performance, and more. In this course, we're going to get past all that. We're going to think like the people that make these frameworks. And my goal is to put you in the best position possible for the rest of your web development career going forward. All right, it's time to understand modern JavaScript frameworks. Let's get started. For this course, setup is fairly straightforward, and it's going to be a bit diverse. So in order to be set up, you can really just think about 2 things. 1, you'll need a code editor. Now, my assumption with this course is that you already have an intermediate understanding of JavaScript. So you're probably already using a code editor, but for this course, we'll be using Visual Studio Code, which you can find at code.visualstudio.com. Along with that, the assumption is you have Node and NPM installed because that's generally what you need in order to get any of these frameworks up and running locally. Another option is to use stackblitz.com, which lets you run most of these frameworks in the browser. You can quickly start up a new project and give things that will look at a try. Whatever the case, we're going to be looking at particular JavaScript frameworks, getting them up and running, and then taking a look under the hood at their source code, at what's delivered to the browser, and how they really work. So if you have a code editor ready to go, and you can install some software from Node and NPM, and if you're not ready to install software from Node and NPM, you can go to nodejs.org and install it, which will install along with it Node Package Manager, which will let you quickly download the code for these frameworks and have an environment for them to run in. So if you can grab the code, edit the code, and run the code, you're ready to go. And if you choose to use StackBlitz or something like it, you won't need to use Node locally. Again, it will all be running in your browser. All right, let's move on. What's the purpose of modern JavaScript frameworks? They're here to help us accomplish something. And primarily, that thing is creating a user interface on the web. That is, building a software application or website that a user interacts with via their web browser. And building web applications and websites has various implications that underpin the decisions, techniques, and tools found within modern JavaScript frameworks. So in this section, we'll first focus on the web itself, how UIs appear in your browser, the underlying technologies, that is, the core technologies underneath modern frameworks that these frameworks build on top of, and the issues and problems with building complex web applications that could arise, and things that modern frameworks try to help us get past. Let's take a look. In order to understand modern JavaScript frameworks, we need to have clear in mind the underlying fundamentals that they're building on top of. So as we go throughout this course, we're going to build our mental model piece by piece. And we're going to start with HTML trees and the DOM, the foundation of building a UI in the browser. HTML, designed to allow us to mark up documents with meaning, is structured like a family tree. Parents, grandparents, children, descendants, and ancestors. We know, for example, that LI is a child of UL, which is a child of section right here. And that means the natural approach to storing a representation of the HTML is a tree data structure. And that's exactly what browsers do. When they receive HTML, they actually build up a data structure inside their code, which is likely C++ code or some other programming language that's a lower level than JavaScript. And the structures that they build up are actually standardized. That standard is the document object model, a tree. We often draw it like an upside down tree with the leaves going outward toward the bottom. But as we build web software, our lives revolve around the DOM. So our first big word alert, wherever we use a word that sounds more complicated than it really is, we'll stop to make sure we understand it. So the document object model, or DOM, a collection of objects in the computer's memory that represent the HTML elements that define a web page. It provides the ability to analyze and change the document being presented to the user. That same DOM standard also is a standard for how we interact with that very collection of objects, that tree data structure in the computer's memory or in the device's memory, whatever browser you're using. So we have this mental model. The browser receives text, which is formatted as HTML. It generates objects in memory, the DOM. And the DOM is then used to calculate how to draw what needs to be drawn on the page in the browser, which is often called the process of rendering the page and painting it to the screen. Modern JavaScript frameworks are built on top of trying to optimize this process. So, for example, I've spun up a vanilla project using stackblitz.com. Vanilla meaning just HTML, CSS, and JavaScript, no frameworks. I have some simple HTML, a navigation, a main, a header, and a button. When that's loaded by the browser, what's really happening? Well, let's click on Other Page. Page 2.html is loaded, and what's downloaded is this HTML, this string of information. The Network tab shows me what's actually downloaded, but the Elements tab shows me the DOM that's been built. So this isn't the HTML anymore. This is a window in to that tree data structure, where each of these pieces of HTML are outputted representing what's actually happening inside the browser's memory. And I can see when I click on one, it's able to be highlighted on the page because this DOM structure defined how the web page itself visually was rendered to the screen. You'll need to keep all of that clear in mind to understand modern JavaScript frameworks. And even though it sounds basic, it's easy to lose your way as we add layers of abstraction and complexity. So never lose sight of the fact that it's HTML that becomes the DOM, that becomes what you see in the browser. Expanding on this idea of the DOM is a core concept for JavaScript frameworks, which is DOM manipulation. It's something a long time ago we used to do more manually. We used to do it imperatively, but not as much anymore. Which, by the way, big word alert, imperative programming. A style of programming in which you describe how a program should accomplish a task. That means every minute step is programmed by you. That's different from declarative programming. Big word alert. Declarative programming is a style of programming in which you describe what you want the program to accomplish without describing how. That means that you do some programming, but you're sitting on top of other people's programming. A declarative system is always built on top of an imperative one, because there's some code somewhere that needs to tell the computer what to do. This would be like writing a routine to teach a robot to tie its shoes. All the minute steps of everything involved in tying the shoe, that would be imperative. And then you came around and there was a function that was called tie your shoe. All you had to do was call that function. That would be declarative. I want the robot to tie its shoe, but there'd be imperative code underneath that actually does all the individual steps. And that's how it's been with DOM manipulation. We said that HTML becomes the DOM which is rendered to the screen. But that render step, that DOM step, that opens up the power because it's not a one-time process. If we can change the DOM at any point in time, that set of elements in the device's memory and the browser's memory, then the browser will re-render. It will update what's visual on the screen to match what the structure of the DOM now defines itself as. And we, developers writing in JavaScript in the browser, can manipulate the DOM via the browser API or the DOM API. API meaning Application Programming Interface. Big word alert. If you're a web developer, you might think of an API as a JSON API, something where you're going out to the internet and getting data. But the term API is really a generic term. It refers to the functions, objects, URLs, whatever it is that define how a program can be communicated with. The DOM can be communicated with via JavaScript. The browser makes that possible. It isn't that DOM API structures are built into JavaScript. The browser makes it available to JavaScript. So, for example, there might be some JavaScript code that says something like append child to a portion of the DOM tree, and then it creates that new element, and the browser will respond to the change to the DOM by re-rendering. And so the web page or web app can behave in what's called a dynamic way. It can change. So, when we think about what's going on inside the browser, there's really two sides when it comes to the DOM. There's the browser itself, and inside of it are two engines. The JavaScript engine, often written in C++, that's running the JavaScript. And there's the rendering engine, also often written in C++, that takes the HTML, generates the DOM, and outputs or prints, renders, paints things to the screen. And the browser, because both are living inside the browser, has given the ability to JavaScript to manipulate those data structures that are actually defined in C++, the DOM. Those are called browser APIs, and there's other browser APIs, but the browser API we're talking about in particular is the DOM API, a standard set of methods and objects that allow us to interact with the DOM in the browser's memory via JavaScript code. Let's go back to our vanilla example. We have a script tag that's going to a script.js file, so it will download this JavaScript and execute it. Because it says type equals module, the JavaScript will be parsed in parallel with the HTML, meaning it will be analyzed, but it will be run after the DOM is actually available, after those elements have been created inside the browser's memory. The point being that I can use the DOM API, one of those browser APIs, to manipulate the DOM. So for example, I'm going to go get the button that's on the page. I sent HTML that defined a button, which means a DOM element for that button was created and is part of the tree in memory. When I say document, that's the entire HTML document, an object that represents it. This document object is not part of JavaScript. It's available to JavaScript, thanks to the browser. And it has methods like getElementById. The button has an ID called ClickButton. So I'll just go get it. I'll also get the heading, document, and I can do what's called a query selector. Query selector lets me do selections similar to how you do with CSS. So I'll say, look for H1s. Let's do a bit of DOM manipulation. The heading variable now contains a reference to this H1 element in the DOM tree structure. It has a property called text content, which I can set to whatever I want. Let's go to the home page. I refresh, and I see hello. That's not what's downloaded, though. If I go to the network, refresh, what's actually been downloaded says homepage. What the DOM becomes after the JavaScript is run is hello, because this runs right away. Note that if I took away type equals module, because the script is in the head tag, it would try to run before the DOM is actually generated. As a result, it still says homepage, and I get an error. Uncaught type error cannot set properties of null, setting text content. It couldn't find the DOM element because it hadn't been created yet. The head is processed before the body, and so there was no DOM elements even though it had HTML. But when I put back type equals module, I could also put defer, and that would do the same thing. Then it's going to not run this JavaScript until it's actually processed this part of the string, this part of the page, and generated those DOM elements. So now they're available to interact with. Now, let's suppose we let this wait a couple of seconds before we do that. Then we can watch the browser re-render the page. Refresh, homepage, wait a couple seconds, and there's the change. I can see it happen here too inside Google Chrome with the elements. See it flash? There it changed. The DOM was manipulated by my JavaScript, and so the browser effected an update to the UI. Updating the UI dynamically has been around for a very long time, but it's another one of those things that modern JavaScript frameworks wrap some abstractions around to make our life easier. There's one more aspect of interacting with the DOM that we need to discuss to have as a baseline. We're going to talk about events, which ultimately make the UI interactive, along with the DOM manipulation that we've talked about. Now, this course is about modern JavaScript frameworks, but we're building our knowledge in a progressive order. So I'm asking you to bear with me. Trust me, this will be important later. Let's look at how events work in the browser. The DOM API lets me respond to events, things like clicks, mouse overs, etc., with functions. So when the event occurs, the function will run. For example, I already have the button selected, so I could replace this set timeout with button.addEventListener. The listener is the function that will run when the event occurs. The event is defined by a string, click. I can get rid of this. That was from set timeout. So now I have a function that will run when the button is clicked. There's now an event listener. When I click this, the heading content changes. So that's fairly straightforward. But we need to talk about a few other aspects of events. Suppose we have the DOM. When I add an event listener, then when an event occurs on that DOM element, my JavaScript function is run. So I might have a click event. But there's more than that. I have a target. What element received the event? And then I have my handler, essentially the function that runs when the event occurs. I can actually see the target because the browser will pass an object to the event listener, to the handler. I'll move the output here of the page to its own tab to give us a little room. Then I'll output this event object that the browser created and passed to our function. When I click, I get this event object. It's a pointer event object. And what's more, it has a whole lot of properties on it. One of them, for example, is target. The thing that was clicked, the DOM element that was clicked, if I hover it, you see it appear over here, the hovering, hover over it, the button with ID of click button. When I go back to my index page, notice that's the ID of the button. So the event object has a whole lot of things, including the target. And the target is important when it comes to modern JavaScript frameworks. We'll see that later. One issue, though, is that adding a lot of event listeners can get problematic, especially if you're creating and removing different DOM elements all the time. You're adding a lot of separate functions, a lot of memory space potentially, and some potential issues for forgetting to clean up those functions at a later date. We also need to think about the fact that when I click one element, I'm also clicking its parents in a way. This gets into what's called event bubbling. Big word alert. Event bubbling. Browsers handle event bubbling. That means handling the event on the innermost element and then moving up through the ancestors to handle the same event. So something is clicked. The ancestors have also been clicked. And so they could also need to handle their own clicks, handle that same event. The order with bubbling is from the innermost to the outermost, from the descendants up through their ancestors, like A, then Li, then UL. To see an example of this, I asked an AI to give me some examples to show you, and it did a really good job. I just had to make a few adjustments. So the first example we'll look at, we've already seen a click event being handled, is bubbling. Here over in the code, in the HTML, we have a bubbling example, which has an outer section, a middle div, and a button in the middle. So when I click the button, it should handle the event on the button, then the event on the div, then the event on the section. If I just click the div, it should handle the click on the div and then the click on the section. If I just click the section outside of the div, then it should just handle the section by itself. The code looks like this. I get each of those elements, the outer section, the middle div, and the button, and then add an event listener for each of them. An event for the button, which will change the background color of the button because we're changing the target, which will be the button, style, which is the style attribute, and then the background color of that, basically setting the style here in code. Then a click event on the middle div will do the same thing, change its color, and a click event on that outer section will change its color. What will help is the console.logs that we put on each. So if I just click the section, then only the outer click occurs. If I click inside the div, which has this dashed border, I'm also clicking the section, but the div will get the event first. Click the div, and I see the middle, but the outer clicks again. Notice the middle happened first. And then if I click the button means I'm also clicking the middle div, and it also means I'm clicking the section because the button's inside of them. But the button will get the event first. Button clicked, then middle, then outer. The event bubbled up from the lowest level descendant up through its ancestors, the closest thing that I clicked up through the DOM tree. That's event bubbling. There is another option you can opt into via the DOM API. That's event capturing. It's the same idea as bubbling, but in the opposite direction. Whenever an event is captured, the outermost element will handle the event first, whichever elements actually have an event handler in order to actually run. They will run from the outermost to the innermost element, from up the tree down into the ancestors. So, big word alert, event capturing, handling the event on the outermost element and then moving down through the descendants to handle the same event. So if I clicked on a lower element, the click event that runs would first be whatever's been attached up the tree and then down. In our example here, if we look at the code, we have a capturing example with the same structure, a section, a div, and a button. Then we grab those DOM elements and we add event listeners, but with a third parameter, the name of the event, the handler or the listener, and then true for event capturing instead of bubbling. And each of these elements will get their own event with a console.log and changing the background color. So if I click the button's click event won't be handled first. There's 3 click events that could be handled, section, div, and the button. And because I'm doing event capturing, the outer goes first, the section, the middle, then the div, and the button. And that's the reverse order of the bubbling example above. If I just click the div, I get the section and then the div, and then if I just click the section, I get the section by itself. So event bubbling and event capturing is about taking whatever element has received the event, the target, and making sure that any other elements up its ancestry, if they have listening events, will get those events run. In what order depends on bubbling versus capturing. The two together are called event propagation. Big word alert. Propagation is the idea of transmitting something in a particular direction through a medium. Sound propagates through the air, for example. But big word alert, event propagation is the idea of the event essentially being propagated through, moving through the DOM tree. So that includes both bubbling and capturing. It's the act of movement. The event doesn't really move, but the code for the browser is handling the events in a particular order, like the event was being moved through the DOM tree. That all said, there's one more important concept for understanding modern JavaScript frameworks when it comes to dealing with events, and that idea is event delegation. Big word alert. Event delegation is assigning an event handler to an ancestor node in the tree. And then in code, you figure out what function to run based on what was actually clicked. So instead of having a bunch of different listeners in the DOM tree, you consolidate to a single listener higher up the tree. This can improve performance and memory usage. And then when something is clicked, because of event propagation, eventually that click will be handled by the function in the listener up the tree. And you can then determine which element was actually clicked, going down as far the tree as you can, to then decide what needs to happen. For example, here I have an unordered list with an idea of delegation list, and 5 list items. I'm not going to put click handlers on the LIs. I'm going to delegate to the unordered list. In the code, I get the unordered list from the DOM, and then I add a click handler. The browser will pass the event object to that handler, and there's a property on the event object called target. Event.target gets me what was actually clicked. So if I click on an LI, that's the lowest part of the DOM that was clicked, then it will be that LI item, even though the UL is actually handling via event propagation the click. If I was to wrap item 1 in some other element, then it would be that element. And I would have to deal with that DOM structure, maybe look for an LI ancestor to select that LI if that's what I wanted to do. But in this case, it's going to be an LI that's the target. So I'll double check. I can check the tag name. This is all DOM references that the browser provides. So I can say for the click event, what was the lowest level DOM element that was actually clicked? What's its tag name? If it's an LI, then I'll add something to that target's CSS classes. And I'll have a little bit of code here to add dash selected to the text of that LI. And I'll log to the console which item was clicked. When I try this in the browser, I click on an item, and the UL is going to actually handle the click. But the target will be that LI. So if I click the item to LI, that LI was the target, so it got the updates that I coded. But there's only one click handler. So I can do all these different clicks, and it's only calling one function, the click handler attached to the UL. I've delegated the responsibility of handling the child events to an ancestor. And that is event delegation. When I go to look to change what happens on clicks, I only need to look in this one spot. And there's only one function in the browser's memory handling all those clicks. So if you imagine that I have a much larger list, maybe something that was outputted from a database, instead of creating 50 or 100 different click handling functions, I've delegated just to the UL. So no matter how many different LIs I have, I'm only going to have that one function in memory. All right. So event bubbling, event capturing, event propagation in general, and event delegation. These are fundamental underlying concepts that modern JavaScript frameworks rely upon. And we'll see more of that as we move forward. There's a fundamental problem, a limitation that modern JavaScript frameworks are trying to abstract us away from. But that limitation is also the foundation of the internet, and really is a key reason why the internet has flourished. We're going to talk about HTTP and the client-server boundary. In many ways, modern JavaScript frameworks are trying to pretend this boundary doesn't exist. And while that can have benefits for us as developers, it also leads to a lot of the complexity that we see in the JavaScript ecosystem. So first, let's get our foundation under us for this core concept. When we talk about HTTP, we're really talking essentially about sending text back and forth between a server and a client on the internet. So what do we mean by HTTP? Well, big word alert. Hypertext Transfer Protocol. That's a set of rules and really a format for data being transferred on the web. So when I make a request for something on the web, like a web page, and then the server gives me back the web page, there's a standardized way of doing that, a standardized format that both the browser and the server are coded to follow. That's a protocol. It's primarily intended for transferring hypertext, meaning really HTML. But of course, we do a lot more than that these days. But when you think about an HTTP request or response, you're really thinking essentially about a specially formatted sequence of text, kind of like a specially formatted text file being sent across the internet. So I have things like, what's the status on the response of this request? You asked for a file. Is it there? Can I give it to you? And then there are headers, and headers can have a variety of uses. In fact, a server can even code its own custom headers. And on the browser, you could code looking for custom headers to do whatever you want with those particular headers. JavaScript libraries and frameworks that deal with server and client code actually do that quite a bit. Plus, there are the standard headers that browsers and servers by standard, by convention, will include as part of the request or response. And there will be the body, the actual content itself. So the status and the headers is really information about the request, and the body is the thing you're actually looking for, like in this case, some HTML for a web page. HTTP is a stateless protocol, and this is important. The server has no memory of previous requests. Every new HTTP request is treated as a completely new and standalone interaction. Now, there are other APIs and concepts on the web that are two-way, like WebSockets. But HTTP, the foundation of the internet, has always been stateless. That means I send a request, I say, give me this web page. And when I refresh, say, give me this web page again, the server doesn't say, oh, you requested it before, so I'm going to give you only a portion. No, the server and the client are coded simply to say, here's a brand new request, like you're starting from scratch. Now, there are ways around being stateless, but underneath it, HTTP requests and responses are stateless. There's no memory on the server of the request that you previously sent. That's actually allowed the internet to flourish because it makes for a very simple and straightforward protocol to implement and debug. However, modern web applications really want to be stateful. We don't want the page to refresh and change and clear and start over every time. We want things we've put in form fields to stay there when there's an error, for example. So much of what frameworks do today is about pretending that HTTP is stateful, not stateless. That pretending really means a layer of abstraction. It provides both a lot of power and a lot of complexity because modern JavaScript frameworks are trying to make the internet behave as if it was something that it isn't. We'll see more of that as we go along. For now, remember, if I go to a browser and I go to a web page like the courses page on my website at tonyalisea.dev, I can open Developer Tools and go to Network in Google Chrome, refresh, and I can see the requests. I can go to the request for the actual courses page, for example, and I can see the headers. They're broken out for me to make it easier to read by Google Chrome. So here's what came back in the response, for example. What's coming back is HTML. Here's the date. Here's the server that's serving it. The browser built the request. The browser built the HTTP request and all of its headers. And so it says things like, well, the method is get, the language is English, and so on and so forth. The actual response is the actual HTML that the browser is then going to use to build the web page. So there was a request built by the browser, which was a full HTTP request, and there was a response given back by the server, a full HTTP response. But if I refresh this page, notice that it's a complete new request with all of that same information. It didn't say, oh, well, the last time I told you I'm sending back text HTML, so I won't include that this time. No. Everything needed to process the request and the response is always there every time. It's stateless. That's both good for the internet and bad when you want an app to behave as if it was like an installed app, like on your phone or on your computer. All right, so keep this in mind, and we'll talk a bit more about this in our first Stack Dive challenge coming up in just a bit. There's a term I want to introduce to you that you'll hear as we talk about modern JavaScript frameworks. That term is the server-client boundary. In modern frameworks, we're often crossing that boundary, the boundary between two halves of a stateless system. So what is the client-server boundary? Well, it's actually pretty straightforward. We have the client, usually the browser, sitting on a phone, laptop, or desktop. Then we have the server, or perhaps multiple servers acting as if they were a single server out in the cloud. The client makes a request, a standardized format of information, essentially a text file, and the server responds, again, in a standardized format. This is the way the two halves of this client-server relationship communicate. They communicate across a boundary, what's commonly called the client-server boundary. Crossing that boundary is very clear when you're doing the work manually. You make a request from the browser. You handle a request and create a response on the server. But when dealing with modern JavaScript frameworks, that boundary is often abstracted away from us in some way. That can make it feel like the browser and server are one unified system, but really they aren't. And if we keep in mind that the browser and the server are separated by this boundary in a stateless system, that every request and every response is complete, we can understand why JavaScript frameworks make a lot of the decisions they do, why they work the way they do, why they have to work the way they do, and the problems they're trying to solve, as well as the problems they create at times with their complexity. If you can keep this simple truth in mind, a stateless client-server boundary, you'll have a far easier time debugging problems in modern frameworks. We'll see a lot more of this as we go on. It's time for your first Stack Dive challenge. Because in this course, we're not going to learn how to use all these different frameworks, but instead we're coming to understand how they work and why they work the way they do. We won't have projects like we typically do in a lot of coding courses. Instead, I'm introducing something I'm calling the Stack Dive Challenge, which means we're going to help you be more curious, a deeper dive into how things really work. This first Stack Dive challenge is HTTP curiosity. So here's what I'd like you to do. I'd like you to keep the network tab open in your browser, developer tools, network tab, and look at requests and responses for a site that you're interested in, preferably something that you've built or are working on, or something else that you just enjoy using or are interested in. As you use it, keep the network tab open. Look at the various requests. Look at the values of the headers. Look at what's coming back in the response. And then be curious about it. If you're doing a search, maybe you talk to an AI about it, an LLM to get some more information. Post in the comments here on this video. Tell us about what you found. Get accustomed to thinking about how things really work. It's going to make a massive difference in your capabilities and your frustration, your debugging ability as a developer. All right, I'm setting that challenge for you. So please try to get it done. It will be of a benefit. It's also building good habits that will help you as a developer. I hope to see something posted from you, and we'll see you later. JavaScript frameworks are trying to help us organize our application's code and avoid doing manual DOM updates, among other things. The way they do that does have a degree of consistency. This is components, trees, and state. To think properly about what modern JavaScript frameworks are doing, we need to think in terms of subtrees. Developers who come in and learn web development primarily from frameworks sometimes lose sight of the fact that ultimately what we're presenting to the user is based on a complete DOM tree. The entire tree is what's sitting in the UI, because frameworks help us focus on subtrees. And by subtrees, we mean when we have a tree of DOM elements, say a main and then a section, and then maybe it has a paragraph and a button, and somewhere else there's an unordered list off of main, we can think about sub-portions of the tree. That is, a subtree. In this case, we can zoom in and focus just on the section as if section was the root of a tree itself, knowing that it's actually connected to and part of the larger tree. If you think about the user interface on the web as one massive tree, then subtrees are ways of subdividing our focus, our intent, our code, our logic, and a way to make something reusable. If this subtree section was really needed multiple times, then it's reasonable to think of the subsection as being repeated within the broader tree. If you could focus on the logic of that subtree, and give it its own necessary information in order to present itself, like what's the text of the P, what's the action that happens when you click the button. Then you have a reusable portion of the subtree, being able to keep us more focused in two ways on smaller pieces of the tree that we can focus on, and potentially making those sections, those small subtrees, reusable, repeatable, is the foundation of how modern JavaScript frameworks have gotten so popular. But an experienced developer concerned with performance and understanding the reality of what frameworks are doing for us aren't just thinking about subtrees. We're thinking about the entire DOM tree that's created along the way. It's time for a conceptual aside. This conceptual aside is stateful versus stateless. And in particular, we're looking at HTTP versus the DOM. So, big word alert. Stateful. A system is stateful when it remembers information from previous interactions. So, let's suppose we had a simple system, a calculator that just adds two numbers. But this calculator is stateful. It can store a piece of memory. So we could say that the number in storage is 1 and our input is 1. So our output is 2. And then it takes that output and updates the memory. The next time we use the adder, we give the same input, a 1, but we get a different output, a 3, because within itself, it's utilizing state. It's stateful. It remembers what happens the last time in some way, and that affects the outputs the next time you interact with the system. That's very different from stateless. Big word alert, we've already talked about this, but stateless is a system where each interaction is standalone and carries all the information needed. So a stateless calculator that adds two numbers would just take two inputs and not have any memory, any storage, any state. Every time I give it 1 and 1, I get a 2. And I have to give the calculator both inputs. I have to give it everything it needs in order to carry out its function at that moment in time. While a stateful system is more powerful in some ways, it's also more complicated and difficult to debug. That's why HTTP won the internet as a stateless system. It's easy to debug, and it lowers its complexity. However, we rely on stateful systems in web development all the time with modern JavaScript frameworks. As a matter of fact, the DOM is a stateful system. When we're looking at what looks like HTML in the elements of the developer tools in the browser, we're not actually looking at HTML. We're looking at a text representation of objects in memory, a tree of objects, the DOM, the document object model. And when a JavaScript framework updates the DOM, so I say count is now 1, this text, count is 1, is stored in the DOM, not in the JavaScript object, but in Chrome's case, in a C++ object. Count is 1. 1 might be state held in a JavaScript object somewhere, but this is held in the DOM. Now I can scroll around the page, I can click elsewhere, and I still have this same count is 1 in the first button. And when I click again, I'll have an update and I can continue to scroll around and do other things, and I maintain the state, even as the browser updates visually what's happening based on the values within the DOM. The DOM doesn't completely reset every time I interact with it. It's stateful. Until, of course, I refresh the page. Then an HTTP request requests new HTML, runs JavaScript all over again, builds a brand new DOM. So I'm really starting from scratch, a completely new set of objects. But as long as I'm on the screen in this session in the browser window, the DOM is stateful and HTTP is not. That tension between stateful and stateless, between the nature of HTTP and the nature of the DOM, is at the core of how modern JavaScript frameworks work. And we'll see much more of that as we go on. So keep this in mind. How do modern JavaScript frameworks help us to focus on reusable subtrees and encapsulate our code and logic in a way that's easy to manage? Well, the entire concept is called components. Just like we think of the DOM tree We can think conceptually of our components as a component tree. There are DOM elements that will end up in the DOM, but JavaScript frameworks allow us to define where a component sits as a subtree, and then whatever that component generates is what ends up in the DOM. Some frameworks, like React, literally have a tree of JavaScript objects that store this definition. We'll talk about that later. Some JavaScript frameworks, like React, literally have a tree of JavaScript objects that they hold to store this tree construction. For others, it's more conceptual in that we reference the components in each other's code, which allows the framework to determine how to write code that will build the DOM. We'll see more of that later as well. But conceptually, we can think of an encapsulated component, an object or a function that serves as a unit of encapsulation. Our logic, our code, our response to any events, and the definition of what the DOM should look like live in that component. What's more, components can be composed. Big word alert. Composition. That means building complex UIs by combining smaller reusable components together, like functions. I could write several functions and have them call each other. I can compose the functions. Similarly, JavaScript frameworks allow us to compose components. I could have a greeting component that contains a counter component, and so on and so forth. These composed components is where the power of this entire concept really comes from. I can make things reusable. I can nest my logical concepts. I could have a counter inside a greeting and the same counter inside some other component. If I change the counter component, it changes everywhere that it's used. But in the end, we're always talking, when it comes to web frameworks anyway, about delivering a final DOM and code that runs when events happen. Here's an example using Vue in StackBlitz. I set up a basic Vue application, and I have a counter component in this counter.vue file. It defines a section and a button that handles the click. But that counter component can be referenced by another component, like this one, hello world. And I can use more than one instance of that component, and I'll end up encapsulating that same logic more than once, but generating a repeat subtree, although that subtree may be adjusted based on certain parameters. But in the end, what I want you to be thinking about is the final DOM. Here's an example where we have two hello world components being used here inside my app, but ultimately they output DOM. So if I inspect these elements, I can find the entire article here that defines the hello world repeated. And inside of it, it has two counters, each of which was inside a section, and those are repeated. So if I had a big loop and I was outputting lots of components, when I'm working in the JavaScript framework, it can feel like I'm just working on small files, which is good for how we can think through the logic of our application. But ultimately, everything is about what the final full DOM looks like. Updating the DOM while keeping our logic and code encapsulated and reusable is at the core of modern JavaScript frameworks. All JavaScript frameworks have to deal with state. Well, really, all programs have to deal with state, and JavaScript frameworks are no different. So let's talk just a bit about state and state management, the input to the system. Once you have components, some list of individual pieces that manage their portion of the tree, their portion of the application, that can be composed, combined together, you need to know then what the output actually needs to be. And that's where state comes in. State is the set of information that defines an application at any point in time. So if I have a particular state, let's say a set of counters and each one has a current value, then the components that output those counters ultimately generate some kind of representation that will be eventually translated into the user interface, something that will ultimately be seen or interacted with by the user. But it starts at its core with just the information. And generally, JavaScript frameworks handle state in two different ways. Either the state lives very close to the component or within the component itself that needs that state, or the state is given to a component from another component, passed to it in some way. Either way, the component needs the state, the information, the set of information needed to calculate what the user interface should look like, and that will be provided in some way by the system. But from a practical standpoint, what does state really mean when we're sitting inside a browser, for example? Notice that in the example of the counter, as I click, the browser doesn't refresh. It doesn't make another HTTP request requesting from the server saying, here's the new count, and storing the state on the server somewhere. Instead, the state is stored in the browser. Now, we said HTTP is stateless. JavaScript frameworks are doing a lot of work to make web applications feel stateful. And one of those is storing state in the browser. Now, it's not storing it in the DOM necessarily. Usually, it's storing it inside JavaScript objects sitting in the browser window. Because JavaScript, the JavaScript engine running in the browser, is also stateful. Until you refresh the page, you're going to have the same state. It's not going to start over. It's not going to clear. If I have a value in a variable, it's sitting there. And frameworks like Vue, for example, use that. So if I inspect this counter and I go to this section .card, I'm going to go to the properties of this DOM object. And notice it has not only its own properties, but Vue has attached some JavaScript objects to it. This is very common in JavaScript frameworks. Attached to the DOM elements that were created by a component as a result of a component, you can go find the JavaScript objects that were involved that store a particular state. If I go instead to this Vue parent component, I'll see what I am. I'm actually inside the counter under this type property. It's counter, that's its name. So we're looking at one of our counter components. What's interesting here is that now I can go find under exposed the count property. And it has a value of 3. That's the current value. If I update this to 4, well, this won't automatically update. But if I move away, move back, reopen it, there's the value, 4. This state is responsible for the DOM being updated to match the state in some way. The state plus the components resulted in the UI. How state gets to UI is different in different ways per JavaScript framework, but the core concept that state is used through components to ultimately generate a user interface is universal to JavaScript frameworks. It's typically the APIs that are different. And by that, I mean the particular methods, functions, objects, standards, etc., that the JavaScript code, the JavaScript framework is written in is exposing to you, the developer. So here, define expose allows this count variable to be exposed, but that also means I can find it here in this exposed property on the actual under the hood object that's being used by Vue to store state. So when you think about state and state management with JavaScript frameworks, for the most part, we're dealing with the fact that we don't want to always refresh the page and go back to the server because HTTP is a stateless system. We often want an experience for the user where they're just doing things on the screen and the screen changes. And that's done in large part by maintaining state in the browser somewhere in a JavaScript object. Within components is not just state, but logic. And logic generally is about what we should show on the screen at any point in time as a result of the state. This is templating, interpolation, and logic. Every component in a JavaScript framework needs to do its job of taking state and deciding what should be shown or interacted with by the user. And across JavaScript frameworks, we have one consistency: templating of some kind. For example, in Vue, I might have a template element, and inside it, I define what this particular component will do with the state, how the UI should appear, how it should be interacted with, all bottled up in this component. And if you reuse the component, then you get that same output if you get the same state over and over again. But this is a matter of syntax. Vue has me write something that is basically HTML. I've opened up a Svelte project in StackBlitz, and here's a counter component in Svelte. I still have the same idea of co-locating, that is, putting in the same place my code and my templates, and there is my templating. I've also opened an Angular project inside StackBlitz. And here again, I have an approach. It uses this component concept, which I pass to it an object with different definitions, and in it, I have a template property, which I could point off to a separate file, or I can just put here as a string that then contains this HTML-like content. In all of these cases, we're already seeing what templates need to do. For example, interpolation. Big word alert. Interpolation means basically inserting values or expressions into a string. JavaScript frameworks do a lot of string building and provide ways for us to do that in the template. For example, here in Angular, I say hello from name. Name is a variable with a value, a property on an object in this case. And so using these double curly braces, we can perform interpolation, ultimately causing this entire interpolated string to be used in the DOM, where this value is put in its place. I see the same thing with Vue, where count is count, a similar approach. And with Svelte, I see again a similar approach, just single curly braces instead of double. But the idea is the same. We need to be able to take variables, take state, and sometimes show it, or show certain things based on that state. And so we have interpolation. We also have logic. So in my view, I say, show this paragraph if the count value of state is over 3. So as I increment it, I see it appear. And again, this is syntactic. Vue provides an attribute on the element called v-if. Svelte does it outside the element itself with this if block. Angular, well, if I scroll up here, I made a counter component, and I have an ngIf, also an attribute on the element like Vue. JavaScript frameworks have different approaches to logic, but they're all accomplishing the same thing. What should be the output based on the state? And it's good to think about the fact that that's happening. If I inspect this count in the Vue app, I actually can see an HTML comment, which is a DOM element for the v-if there as a placeholder. Then when the count passes 3, that placeholder is replaced with the paragraph. Think about the things the JavaScript framework has to do in order for the logic to work. As the logic is run, it needs to update the DOM. It needs to know where to update the DOM after it's initially created. Svelte actually does something similar. If I inspect and then increment the count, I can see that there's, again, a DOM comment there, an HTML comment element in the DOM. And when I go past 3, it's replaced with a paragraph. Not every JavaScript framework will handle this the same way. But I encourage you to open up the DOM as you're interacting with whatever app you're building, with whatever framework you're using. Watch the DOM update. Keep in mind that this is code running and not all your code. A great deal of other people's code that makes up whatever the JavaScript framework is. And they have to do different techniques and tricks to do things efficiently, performantly, and clearly, while you simply deal with the syntax they've provided. Whatever that syntax is under the hood, the approach is the same, and the purposes are the same. What may differ is what they're exposing to you and what's important to them, how they think they can make their JavaScript framework the most performant and the best experience for the developer. But don't worry so much about syntax. You'll have syntax that you enjoy more than others personally. But in your career, you may find yourself moving from syntax to syntax to syntax. If you keep in mind the purposes and that it's all just other people's JavaScript under the hood, you won't be afraid of changing syntax because you understand it's just other people's JavaScript code trying to accomplish the same things. It's time for your next Stack Dive challenge. I'm challenging you to look under the hood and to be curious. It will improve your dev life in so many ways. So for this Stack Dive challenge, I'm encouraging you to have curiosity about state. And I'm asking you to take an app you're working on, take a framework you're interested in, whatever the case is, just spinning something up in StackBlitz quickly or something like that. Go ahead and try to look at the state where it's stored. Try to find it and think about the fact that there's really just JavaScript objects floating around in the memory of the browser whose structure, where that state is stored, is defined by the JavaScript code of the framework you're using. But they're not all going to be the same. Let me give you a couple of tips. Sometimes you'll find state hanging around when you look at a particular DOM element. The JavaScript framework has attached some JavaScript objects to it, which may give you a clue as to where state lives. In other cases, for example, like Angular, you don't really find too much in terms of state when you actually look at the individual DOM elements. What you do find, for example, with Angular is ng context, which turns out to be an index, a number that gets you down into, you guessed it, a sequence of JavaScript objects. Well, I can start incrementing state, and then in the inspector in Chrome, I can reference this DOM element, whatever DOM element I have selected, with $0. So if I select app counter, notice with Angular, I actually see those elements there, my custom component, which you don't see in something like Vue. But if I select it, now $0 will be that app counter. I'll go to console and I can say ng for Angular.get component. And then if I do $0, which will be that current component, there it is, it's the counter, and there's the state. So you may need to do some research. Have an LLM help you, maybe within its training data or by searching, it can find some tips for you. Go ahead, look at an existing app or make a Qwik app, and then find the state. And keep in mind that the state is going to be sitting in JavaScript objects. It's not just a black box. You can go in and find where it is. Have fun and let me know how it went in the comments. All of this we've talked about so far is building a foundation, because as we get into the even more complex things that we find in JavaScript frameworks, we'll build on this curiosity and on these concepts that we've established. So have a great time with this Stack Dive challenge.
So how are your Stack Dive challenges going? Let me know in the comments, and I hope you enjoyed this first hour of understanding modern JavaScript frameworks. There's a lot more to come as we talk about signals, as we talk about server functions, as we talk about bundling, as we talk about routing, and so much more. So I hope you'll join me in the full course and learn to grow beyond a user of a particular abstraction, a particular framework, but a dev that deeply understands. You can find the link to the full course in the description of the video, or you can go to don'timitate.dev to find my mastery path for growing from a dev to a lead to an architect. Happy coding.